Today, we're diving into the story of a number that, by all accounts, shouldn't even exist. A mathematical ghost that haunted the world's greatest thinkers for centuries, before it turned around and completely changed how we understand reality itself.
All right, let's just get right to it. Why would anyone invent a number that seems impossible? I mean, we all learn this in school, right? A negative times a negative is a positive. A positive times a positive is also a positive. So the square root of a negative number? It's like, where do you even go with that? It feels like hitting a mathematical brick wall. Now, you might be thinking, oh, I know this one. It's for those equations like x squared plus 1 equals 0, the ones that just don't have a real answer. But here's the twist, and it's a big one. The real story is so much weirder. Imaginary numbers weren't born from problems with no solution. They were practically forced on mathematicians by problems that absolutely 100% did have real, solid answers. So forget about those simple parabolas for a second. Our story actually starts way back in 16th century Italy, where the best mathematicians of the day were locked in a battle with a much bigger beast, the cubic equation.
Okay, picture this. It's 1572. A mathematician named Raphael Bombelli is staring at this exact equation. And, just by looking at it, you can probably see a solution. 4. 4 cubed is 64. 15 times 4 is 60, plus 4 is 64. It works. It's simple, it's obvious. He knew x equals 4 was a perfect, real answer.
But, and this is where the story takes a sharp turn into the bizarre, when Bombelli plugged this problem into the official, fancy new formula for solving these things, it didn't just give him the number 4. Oh no. It spit out this thing. This absolute monster of an expression. And look right there, smack in the middle of it, the square root of negative 121, the very thing that's not supposed to exist. So what in the world was going on here? How could a formula spit out something impossible just to get to an answer that was not only possible but obvious? It was like having to travel through a phantom world just to get back home. This maddening paradox got a name, the casus irreducibilis, the irreducible case. It was a total head-scratcher. And for the next 200 years, that's pretty much how mathematicians treated these numbers, with total suspicion. They were like this mathematical ghost in the machine. A handy trick, maybe, but not a real number. No way. I mean, listen to Girolamo Cardano. He's the guy who first published the formula. And even he called working with these numbers mental tortures. He knew the answer was right, but the journey to get there felt just wrong.
And get this, the very name we use, imaginary, was actually meant to be a put-down. The famous philosopher and mathematician René Descartes just threw it out there as an insult, basically. He was like, these numbers aren't real, they're just imaginary. He thought they were complete nonsense.
Even our guy Bombelli, the one who first wrestled with this and showed, incredibly, that those two freaky imaginary parts just, poof, cancel each other out to give you the number 4. Even he admitted the whole thing felt like a magic trick, based more on sophism than on truth.
So for more than 2 centuries, the square root of negative 1 was this algebraic ghost. It worked, but nobody had a clue what it actually was or what it represented. It was a tool without a home, until someone finally drew a picture. And the hero of this part of the story isn't some famous academic you've heard of. He was a Norwegian surveyor, of all things, named Caspar Wessel. And in 1797, he had this incredible game-changing idea. He thought, wait a minute, what if we've been stuck in one dimension? What if there isn't just one number line going left and right? What if there's a second one going straight up and down? And with that one simple idea, everything changed. Suddenly, I wasn't some spooky, abstract symbol anymore. It had a place. It had a home. It was a destination. You just go 1 unit straight up on that new vertical axis. Every single complex number now had a specific address on this beautiful 2-dimensional map, the complex plane. And this picture, this map, finally shows us what I is actually doing. It's not imaginary at all. It's a rotator. Think about it. You start at the number 1, you multiply by I, and bam, you've rotated 90 degrees counterclockwise. You're pointing straight up at I. Do it again. Multiply by I again, and you rotate another 90 degrees, landing right on negative 1. I squared equals negative 1. It's not a rule to memorize. It's just a 180-degree turn.
It all makes perfect, beautiful geometric sense. You know, the legendary mathematician Carl Friedrich Gauss really hit the nail on the head. He basically said the whole problem was just bad branding. If we had just called them direct for positive, inverse for negative, and lateral for imaginary, well, all that mystery and confusion would have just evaporated. I isn't imaginary, it's just a step to the side. Okay, so once I was given this solid geometric foundation, once people could actually see it, this number that was once dismissed as impossible completely transformed. It became an indispensable language for describing the real world. And this right here is the really crucial takeaway. This number that started out as mental torture is now something we literally can't live without. The electricity powering your device right now, it's an alternating current, and the language engineers use to handle it is built on imaginary numbers. The signal processing that lets your phone work, the quantum mechanics that describes the very fabric of reality, even the computer graphics that generate amazing fractal art, all of it relies on I. And this whole incredible journey from a mathematical outcast to an absolute cornerstone of science is perfectly captured in this one stunningly beautiful equation, Euler's identity. Seriously, mathematicians look at this and see a perfect poem. It elegantly ties together the 5 most important numbers in all of math: 0, 1, e, pi, and our hero I. Just incredible. So the story of I is just this amazing reminder, isn't it? It shows us that sometimes what we think of as impossible is really just a limit of our imagination, not a limit of reality. It really makes you wonder, what other ideas are out there right now, the ones we're quick to call impossible, that are just waiting for the right person to draw the right picture and change everything?